starting to use her notes. You got 15 seconds. When the bell goes off, I want all eyes on me. All right. Need you to stop writing. Let me get everybody's eyes. Get your eyes in. All right. So before we go over this do now, since we got a small class and we're gonna be doing labs anyway, Anthony, can you come sit up here with Misael? No, I need you all to come up here. So I need 2 people here, 2 people here, and 2 people at this seat. All right? You got 5 seconds to get there. 5, 4, 3.
So you want all of us out the back?
1.
It's gonna be a hard time.
It is. It is. All right.
Come on. Right here, work.
Come work with Kia. Jordan, can you come work with Janelle? All right. Now let's go over this do now. So, Anthony, can you read me the question for number 1? So we're comparing and contrasting active and passive transport. So in this first section, you were supposed to write things that were just about passive transport. Can you give me one fact about passive transport, Rakia? Absolutely. So there was no input of energy. There's no input of energy. So how is that different from active transport? Go ahead.
Active transport requires energy to move particles.
It requires energy. All right. So let's keep going on passive transport. Misael, can you give me a fact about passive transport? That it doesn't require energy? Yeah. Okay, so what are two types of passive transport? Can you get that to me, Misael? 2 types of passive transport.
Osmosis and diffusion.
See? You knew more than you thought. So we have osmosis and diffusion. All right? What do we know about the concentrations of these 2? Do you know anything about the concentration, Janae? Yes, Jordan. Great, Jordan. So they move particles across the membrane. All right? So, in passive transport, because it requires no energy, matter of fact, let's go active transport. How are the particles moving? What concentration levels are they moving toward? Is it going from low to high or high to low?
High to low. Wait. Low to high.
What is it? What is it? You said what? Low to high? Why is that?
Because it doesn't really need the little thing the flap that opens to take a...
So you're thinking about the protein pump.
Yeah.
So the protein pump, absolutely. So it goes from low to high. All right? So it takes energy to move particles from a lower concentration to a higher concentration. It does not always take energy to move from a high to a low. And this is in the case of diffusion. High to low in diffusion. Okay? So we can actually move on. So, Jordan, can you give me one fact about both for question number 2? All right, you can actually give me the same fact that you gave me for the first one. Absolutely. So they both move particles across a membrane. All right? And Misael, I'm going to come back to you. These are both examples of what kind of transport? Diffusion and osmosis are examples of what? Which kind of transport?
I think passive.
Yes, sir. These are both examples of passive transport, which means there is no energy required. All right? Now we're going to go to the differences. So we've been talking about osmosis, okay? Jaylene, what moves in osmosis?
What moves?
What is moving?
Water.
Water, for sure. So water is moving in osmosis. And, Rakia, does water move from low to high or high to low? Thank you, Jaylene. Water moves from low to high. All right? Now, Anthony, what moves in diffusion? Sugar? Okay. So we're going to go sugar, which is an example of particles. So like particles that aren't water. Okay? And in diffusion, Janae, I know you haven't been here, but I'm going to come back to you. So, do you think it's moving from a low to a high concentration or a high to a low concentration? Thank you. Absolutely. I like the fact that you used what we already had down there for your answer. All right? So, let's move on. We're going to go over the agenda and objectives for today.